Okay, guys, we're going to look at two different areas today. We're going to look at simplifying a ratio and in turn equivalent ratios, and we're also going to look at how you can compare two different ratios as well. So, we've got 3 to 6. 3 parts to 6 parts, 3 equal sized parts to 6 equal sized parts. If we look at this diagram, this top diagram here represents 3 to 6, but if we've got 3 equal parts and there's 6 equal parts on this side, we may as well say, well, we've got 1 part on this side and 2 parts on this side, and they're the same size as each other because all of them are 3 of these equal size boxes. So what you do is you look for a common factor, the highest common factor if we're simplifying it to its simplest form, which is 3, and you take that factor out of it. Okay, now we look at 12 to 8. This time this diagram's a little bit more messy, but you've got 12 equal sized parts and 8 equal sized parts. Now 12 and 8 are both multiples of 4, which means that we can group up these 4s as well, which I've done here, and you could have 3 groups of 4 to 2 groups of 4. So again, we go back to this ratio and we look for the highest common factor of 12 and 8, which is 4, and we take that out of it, and we get 3 to 2. Okay, and as you can see here, that works. They're the same size. My diagram isn't perfect, but if we used equal size boxes that were drawn perfectly, this would be perfect. So that, okay, is simplifying a ratio. Now, if I wanted to find an equivalent ratio, let's say that I wanted an equivalent ratio that had a 5 here, and I didn't know what went here, you can just multiply that by 5. So we need to multiply this by 5. And 5 to 10 is exactly the same ratio as that, it's just not in a simplest form. Another one we could do here is we could say, well, 3 to 2, how could we get to having 8 there? And what would have to go there? Well, this time we'd have to times by 4, which would give us 12. And we know that that's an equivalent ratio because that's the ratio we started with. Now, if we need to compare two ratios, so we're told A to B are in the ratio 3 to 4, B to C are in the ratio 4 to 7. Find A to C. So we need to find what the ratio is between these two parts. So what we do is we write A to B to C, and we fill in the parts we know. We know A to B is 3 to 4, and we know B to C is 4 to 7. Now this is quite a nice one because they are the same. So for every 4 parts of B, there are 3 parts of A. For every 4 parts of B, there are 7 parts of C, which means that for every 3 parts of A, there are 7 parts of C. So what you need to do for this, guys, is you need to put them on top of each other with the correct part labelled correctly. So 3 to 4, A to B, 4 to 7, B to C, and you need to look at the common part and see if you can get it to be the same number. If it is the same number already, brilliant, you can just compare these straight away, but if it isn't, you have to do a bit of work, and we're going to look at one like that now. So start off by doing exactly the same thing, A to B to C. 2 to 5, A to B is 2 to 5. B to C is 1 to 3. We need to change something about this because these are not currently the same. Okay? Can we get from 5 to 1 easily? Yeah, but it's going to involve dividing a 2 by 5, and we don't want to do that. Can we get from 1 to 5 pretty easily? Yeah, we can. We can multiply both of these by 5. And they are equivalent ratios. Now, we've now got two ratios where the common part, B, has got the same amount of parts in both. So, 2 parts A to every 15 parts C. Okay, last example for this, guys. A and B are in the ratio 1 to 3. B and C are in the ratio 4 to 1. So let's write A, B and C. 1 to 3, A to B. B to C is 4 to 1. Now, unlike question 1 of these examples, they're not already the same. Unlike question 2, it's not very easy to get from 3 to 4 or to get from 4 to 3. So we're going to have to change both of them, okay? Now, what number can we get to easily from 3 and 4? 12 is the answer, okay? What have we times 3 by to get to 12? We've times it by 4. So we're going to times that by 4. 1 to 12. What have we times 4 by to get to 12? The answer is 3. So we're going to multiply that by 3. Okay? Now, we've got the same number in the common part of both ratios. So we can write it out, 1 to 12 to 3. For every 12 parts of B, there is one, that's meant to be a 4. 1 times 4 is 4. So to every 12 parts of B, we've got 4 parts A. For every 12 parts B, we've got 3 parts C. We can now compare these. It's 4 to 3, and we're done.